Hello everyone, welcome back to Skill Talk. So in our previous videos we understood what phase is and how to measure it correctly. So in this video we'll be discussing few more things about the phase, or you can say some kind of advanced phase behaviors. Okay, so this will be the last video for our phase series, that is the basic series for that we have started for the phase. This is the fourth and the last. So today what we'll be discussing that why vibration sometimes looks low even when there is actually a fault. Let's just start with the phase cancellation. Okay, so that is the very important concept that is known as the phase cancellation. So what is this phase cancellation? Normally phase cancellation happens when two vibration forces act in opposite direction, right? Let's say one direction is towards the left and another force is towards the right. If two forces are close to nearly 180 degrees, so what we say that these forces are out of phase, right, or 180 degree apart. So there what will happen that their vibration response will definitely get reduced because they will be cancelling with each other. Okay, so always remember this thing, that low vibration is always does not mean that it's low forces, right? So the forces can still be higher, but maybe the vibration is reduced because of this phase cancellation. Okay, always remember this thing. Okay, so now next what we'll be discussing, that we'll be taking one normal example. Let's say that think of two people. Okay, think of two people pushing a door. Okay, so if both push in the same direction, what will happen? The door will be moving very easily. And if one push forward and another one backward, what will happen? The movement will reduce. So in this case the movement is reduced, but the force doesn't, right? So the movement is reduced but force doesn't. So this is exactly what happens in the machines. So this is not in any kind of instrumentation or error, or it's just normally a physics, right? So normally in the rotary machines, what happens, the phase cancellation can happen due to, let's say, motor and pump forces are opposing each other, or any kind of excitation opposing the this structural response is opposing the excitations, or there can be there are multiple unbalanced forces that are cancelling partially each other, right? So what is the most important thing is here that you may see the low vibration, but there is a possibility that there are high forces or high stress is acting inside the shaft or your bearing or your structure. So sometimes that's why you see that, oh, the vibration is low, then why this failure happened, the shaft is cracked, or something bad thing happened, so then you will say, okay, the history of the vibration data says that, okay, vibration is under the limit, so how this happened, so the RC has been carried out and all the stuff. So these are the examples of such kind of things. So what does this mean? That if there is a low vibration, it doesn't mean that your machine is not under stress. Okay, remember this thing, please. So now we will be discussing little bit about the resonance. Okay, so now let's talk about the resonance and how phase play a critical role here. As a machine speed approaches its natural frequency, okay, natural frequency of equipment, you can say, or structure, you can say, what will happen? What you will see here, the vibration will suddenly shoot up. Okay, so the vibration amplitude will increase, but what is the most important thing is this phase will also change rapidly here, right? So below resonance, what will happen? Let's say that the machine is slowly approaching towards its critical speed. So what will happen? The phase is very relatively stable. Okay, and as soon as the resonance it's very close to the resonance, what will happen? The phase will start rotating very quickly, or you can say the very fluctuation will start very quickly, right? And what will happen? That above resonance, the phase again stables, or you can say the phase again settles. Okay, but what will happen? That it will be shifted. Okay, so a rapid change, a phase change, is one of the strongest indicator that there is that how you can identify the resonance frequency of that particular equipment or particular structure. Okay, so normally what happened, that a 90-degree phase shift is normally it's not a random thing, sudden change of 90 degrees. It's not that, let's say that at particular 800 speed your phase is 90 degree, and suddenly at 870 it suddenly changed to 180 or something like this. It's not a normal thing, right? So what will happen, that it indicates that the system is moving from force controlled behavior to the response controlled behavior. So what is this force controlled behavior? Definitely you will be having in your mind that what is this, so force controlled behavior means it's a kind of a stable force that as your machine speed is increasing, I will try to explain you in a simple language, that as your machine speed is increasing, the phase is also is increasing or changing slowly. Okay, so once it will enter to the response control behavior, or you can say once it's entered to the resonance, what will happen? There is a huge shift in the in the phase. Okay, so that suddenly you will see that, let's say that your current phase was 100, then immediately it may went up to 150 or 200 or something like this, right? So that means that your machine was in force control behavior, then suddenly entered to the response control behavior. So that's why you have been always been heard about your senior vibration from your senior vibration analysts or the experienced guys, that we should not carry out the balancing near the resonance because it is very dangerous and the data is not reliable here. Okay, so that's why it's very important that measurements must consider the operating speed also, because the operating speed should not be near to the natural frequency, right? So I believe now it's very clear that why we should not perform the balancing near the critical speed. Okay, and now let's say that you are near the resonance, we are near the resonance condition. So what will happen? So remember, phase will change very significantly even with a very small change in the frequency, or you can say the speed, right? And second thing, what will happen? That vibration will suddenly jump. Okay, and the third thing, what will happen? That the machine behaves very differently during cost up cost down or near the steady speed. So this is the kind of a symptoms whenever your machine is behaving in such a way. That means there is something related to the resonance. You are somewhere near to the resonance speed of that particular machine or particular structure. Okay, so overall phase not only help us to identify the faults, but it also help us to identify the structural behavior. Okay, so normally now we'll be discussing about some of the common misinterpretations, right? So normally many of the people will say that the vibration is low, that means problem is solved. Okay, if the vibration reduced, that means the problem is solved. So this is a very dangerous thing, because just now we have already discussed that how the vibration can be low but the forces are still higher. Okay, so now I will discuss with you that what can be the practical approach that you guys can follow whenever doing the handling the such kind of resonance situation in your machine. So what we will do, first thing, we should always observe the first thing, the vibration amplitude, and the second thing what you will do, you will be always checking the spectrums, and the third you will be checking the phase stability, right? And the fourth thing that you will be observing the phase change with the speed, or you can say the load, and then you can decide that whether these symptoms are related to any kind of a fault related, or any kind of a structure or resonance or phase cancellations, so what it is. So you can very easily identify if you follow this 5 steps approach. So first one, observe the amplitude, vibration amplitude. Second is check the spectrum, then check the phase stability, then the fourth one is the phase changes along with the speed or load, and the last, then you can decide. Okay, so these are the 5 steps that if you will follow, so you can avoid such situation. So overall, to summarize this video, what we have discussed here, the phase definitely can hide the vibration, right? Of course, yes. Phase can reveal resonance, of course, yes. Amplitude alone can mislead, of course, yes, right? And the phase behavior, normally what happens, it separates the expert vibration analyst from the beginners, right? That's why these kind of logics and the simple explanations are not covered in level 1 and level 2. Slowly what will happen, that you will be taking any kind of a course for vibration analyst, so maybe at the level 2 or level 3 they will start teaching you about this, that why this, what is this cancellation, and why and what are the symptoms, and how you can check the things or check the machines which are at the low vibration. You feel it at a low vibration but the forces are high, so how you can check that, right? So now we are in the last phase, so I will be giving you some challenge questions. So the first question, if vibration is low but phase is near 180 degree, please listen, if vibration is low but phase is near 180 degree, then what might be happening? Okay, first question. Second one, what does a rapid 90 degree phase change indicates? Okay, what does a rapid sudden 90 degree phase change indicates? So last one, that low vibration always means low forces. So what do you think? This statement is true or false? Okay, so 3 questions. Please answer these questions in the comment section, and I will meet you in the next video. Next video will be with another topic, or maybe another series related to the vibration. Till now I didn't decided that which topic I will cover, but I am concluding this initial, you can say, the basic version of the phase analysis series. This is the 4th and the last video for that. So meet you with the next new topic in the next video. Till then, please take care.